Jasmina, can you hear us okay? So your mic's
Yes.
not on. Okay,
Yeah.
you said something then, so I can hear you. Great. Okay, I'm going to introduce you now. We've run a couple of minutes over, so we can survive with that. But you're going to be telling us today about challenge-based learning and how to attack, maybe not attack is the right word, but maybe tackle challenge-based learning or challenge-based learning to tackle societal issues through astronomy education. So Jasmina, the floor is yours.
Thank you very much. Sorry, I was a few minutes late. My Zoom decided to be temperamental.
That's what Zoom does.
I'll share quickly. I won't bore you too much with slides because this is supposed to be hands-on session. So I'll just share a few slides to give you introduction. And I can do that. So I'll put it up. So you see the screen?
Yep, and it's in presenter mode. We can hear you and we can see your video. So yeah, you're good to go.
Okay. So my background is I'm an astrophysicist, and I spent a lot of time in Australia. I'm Serbian originally, and then I done my PhD in Australia and went to work at US, went back to Australia, spent a lot of time there. So I'm still associated with my university that I worked for a long time, which is Monash University, where I was a senior lecturer at School of Physics and Astronomy. And so all of my EVAL educational experiments were done there. And I moved this year to Netherlands in order to pursue more this challenge-based learning, which I think it's really, really cool stuff to do, especially in interdisciplinary units like astronomy and astrobiology, because it really offers sort of project-based learning, working on really current societal issues, and also involving governments and in industry and sort of many stakeholders. So, oh, it doesn't want to move now. Oh, okay. So this is where I spend most of my time teaching. So we built in 2014 at Monash, we built PACE studios, which are physics and astronomy collaborative learning environment studios, and they're based on scale-up studios in North Carolina, if you know those. But the idea was basically to move away from the standard lecture lab kind of setup and move really into hands-on workshopy sort of lectorial style of interaction. And of course, astronomy being night, discipline to pursue at night, we could still pursue some of the hands-on stuff during the day, obviously to do with the sun and stuff, and then kind of engage just with the basic experimentation. But what this allowed me really is to listen to the students rather than being in a lecture theater with 300 students who just stare at you with no question. And then usually teaching associates would run labs because there's 300 students, so you can't run labs in small, tiny 20-room places. When we built PACE studios, we could run these labs or workshops with 100 students in a studio, and obviously having a lecturer with teaching associates helping. But this really shifted me to move towards education research, because before it all looks fine, you give your lecture and you say anybody had a question and nobody's having a question, or maybe the two students sitting in front of you, and then you give them tests or exams, and then you're confused why they don't know that seasons are not due to the distance but due to the tilt. You said that 3 times, why they don't know this? So this what kind of motivated me to more education research and understand what can I do as an educator to help students if the way I'm lecturing or preparing activities doesn't get them to move these misconceptions that we know people have. What is it I can do as an educator to design activities or to design resources to help them learn this in a more efficient way? So I really like being in the studios because I could go and listen what students are saying. You kind of on their level, so they open up and they talk to you much more, and they really tell you, what they don't understand. They are not afraid to admit what they don't understand. But also, I started to move away from standard kind of tests and exams because I realized that because students asked me at some point, okay, do you want me to answer this your way or my way? And I remember the exactly same sentence that I heard from Eric Mazur's talk once. And so what you realize is that some of the clever students who really want to expand beyond what we just offer, they can think of things in a much more interesting way, and especially when it comes to topics taught in astrobiology, or for example exoplanets, which is still kind of new area in astronomy. So it really made me move more towards project-based assessment and giving students different levels of challenge, because the courses that I used to teach, they were elective, and they're mainly meant for first-year students, but I would have second and third-year students as well, because they couldn't squeeze it in the first year, but they wanted to do some astronomy. So I would have really diverse learners coming from all backgrounds, and as most of you in US, for example, I know those courses are very popular. So then you have different abilities and different backgrounds, and you want your learners to progress as much as they can within this background that they carry. So I started thinking more and more about these sort of either 2-hour challenges they could do, but which are more about thinking rather than producing something, but sort of more thinking about the process of tinkering about problems and how would you tackle it using astronomy. So another thing that I really liked is that this sort of being immersed with the students really made me realize how insecure they feel about their knowledge, because when we give them tests and exams, they always feel like, oh, you're so clever and I'm not, you know so much and I don't. And then I was saying to them, but you're a novice learner, you don't know this. I've been doing this for a long time. Of course I know a lot, but that's not the point. So then again, I realized that I needed to give them something to realize how much they learned. So I've gave them over the years, I gave them many topics. I tried to kind of mix and match the topics that match my cohort at that year. But I really wanted to go and talk to their friends or family or people and tackle some call with 3,000 sets of data. Do you think that's worth pursuing? Why would you learn from that? Do you think it's important to chase ET? Would it matter for you if we discover some alien life or not? So I really wanted, my intention was for the students to see how much more they know than the general public, because usually general public will answer in a very sort of trivial way or very non-knowledgeable way about these things, whereas they were supposed to then address these responses through critical thinking, knowing astronomy as experts, and then saying, okay, this is logical, this is, as we can see, they're making these misconceptions and so. But over time, I realized that we were getting really interesting answers where, somebody flipping burgers in McDonald's would say, oh my God, I would be so excited if they find aliens. I like to read sci-fi, I'm studying to be an accountant, and that will never be my job, but I love reading sci-fi. I love thinking about these things. And so students started to realize that astronomy and issues in astronomy and how they tackle our earthly life actually acquiring. So this again made me start thinking about how can we give back something to the community, because we were kind of using this for our project and for students to feel that they're actually experts. They realize how much more they learn, and the scientific filter that they gained to understand some of these new discoveries and issues. And then I made a MOOC about Mars. We had, like many MOOCs, we had many guests from different disciplines, and we really wanted to inspire high school students to enroll in science courses, because in Australia we started to have huge decline, less and less students enroll in high school STEM courses, and then of course that transfers to university as well. And this was the time when book The Martian came out, and of course we all fell in love of how beautifully portrays that science is problem solving. So we created intentions from all levels, and we were one of the rare courses, as Future Learn told us, to have this equal distribution from 13 to 83. So we just done basic stuff. We wanted to teach them how could you make water, how you could make oxygen, energy, and how could you build habitat, just the basic stuff to show that the scientific principles are known. Technology is coming along, but scientific principles are known. We made little exercises for them to do hands-on and things like that. But what was really cool is to see that learners would reflect. Obviously, we always compare Mars to Earth for them to kind of to understand how amazing Mars is or how amazing certain things on Earth were, and we're taking them for granted. And so we noticed the learners were reflecting a lot on how we live on Earth. We didn't preach, we didn't how, So what was great is to see how much sharing there was between learners, because, there will be somebody who was a lawyer and somebody who was maybe scientist, biologist, or accountant, but they will all had some hobbies, and they would help each other understand certain concepts. So when we start talking about partial pressure and an issue of going in and out of habitat in Mars, you'll have to worry about pressure and stuff. Somebody would say, oh, I still understand why, because it's a planet, why does it matter? And then somebody said, well, it's like a diving and, it's going deeper. Imagine Earth is like a depth of the sea and Mars is like top. And so it was really great to see this sharing of experiences and how, we explained it one way, but learners could explain in 3 different ways. And also how hungry for information learners were. And although we, provided some extra reading, they would go and search and share even extra material. And what they told us was the most engaging part. It was open-ended, because we gave them a mission at the start that they're designing a habitat for 100 people, right? So a crew of 100 people. And so we gave them some of the indication how you could build this, but we said, this is our example. Now you have to do this with mind mapping. And then, of course, as you know, on Mars, everything's interconnected. So if you first teach them about how to make
Jasmina, sorry.
Later extracted.
Jasmina, can you hear me okay?
Yep.
Sorry to jump in. Your sound is just breaking up a little bit here and there. We wonder if...
Okay, I'll change the room to see whether that helps.
If that doesn't help and showing us the inside of your house as you go.
Maybe turning off the camera helps.
I was going to say, if you can maybe turn off the camera, which is a shame because we want to be able to see what you're saying as well. But sometimes that just drops the broad.
Yeah, that's okay, because I don't have much to talk, so that's good as well. Is this better?
Right now, yeah, it comes and goes every 2 or 3 minutes. We just lose you for 5 seconds or so. But yeah, keep going, and we'll shout if there's anything else we can suggest.
Okay,
thank you. So
what learners told us is what they really like, how open-ended this learning was, because every time, as I mentioned, they had this mission to form the basic setup, and we would give them some basic ideas of how it could be, but in a very, very rough description, because we didn't want to give them prescribed method to solve something. And then, as I mentioned, they would have to as they learn about new challenge, if you made water first and then you have to make oxygen and vice versa. And there was a lot of discussion of which thing is most necessary to make, whether it's oxygen first or water. So we also throw that back at them, saying, do you think this order of introducing challenges was good? But what we saw is so much creativity, so much original thinking, and for people who said, I hated STEM in school, I thought I was never good, and I finally understand what the purpose of science and technology and all of these things, because these problems really require that kind of solution. But what also required from learners is this flexibility, because you just think you found the solution, and then you realize it will be too hungry for energy, and you can't make that much energy straight away. So then you have to go back and rethink your solution that you've done before. And at first we were a bit worried that people will be a bit annoyed with that. because, MOOCs are generally meant to be easy, especially like a 4-week, easygoing MOOC. But learners really, really like that. And it really conveyed to them how complex problems can be and why you can't just go on, find, first solution and go plug it in. You really have to think about, wider applications. So this is my kind of beginning looking into challenge-based learning, which I knew about from Apple's document that was published in 2009 that started to talk about some of these ideas. And this is where you can see that, whoops, there we go. So on the left here, you have the sort of roughly the framework that Apple came up with in work with teachers in high schools and primary schools in US. Basically, they wanted to address disengagement from learning, not just STEM, but general learning, disengagement learning of students. And they realized that, if you challenge somebody at the right level, they generally rise to the challenge. So they came up with this framework where you start with some big idea, usually to have to do with, societal issue. And then you distill that, you find out what are the essential questions you needed to solve that problem. Then you define your challenge because, you can have several of those questions, but you have time to do just one of those challenges. And then within challenge, you still define, kind of like a research project, you have to define your guiding question, as they call it. And then you have to define which activities you're going to do to answer that question. And then you analyze your data, you find out your solution, you implement it, you evaluate. So it's not just, hey, I found a solution, but you actually check whether that works in real world. And then if it doesn't, you iterate and so on. So this started all with kind of primary and high schools, and then it moved in higher education lately, especially in technical universities, because obviously they train engineers, and engineers are the ones who help us build and solve these challenges. So this is a paper that came out last year that tried to conceptually sort of review what is there at the moment and can identify these key characteristics that challenge-based learning needs to have. And so it kind of often starts with global teams. You pick something that you want to solve. It could be issue around energy. It could be, just a general issue about climate change, but you tackle something within that. So basically trying to address some of the United Nations sustainability goals, and really involving students in real world challenges, as they call it, rather than giving a theoretical problem, which often for clever students, they see it as something too easy and they don't get engaged so much. But if you give them a real world challenge and they realize they're tackling something that it's meaningful, they get engaged. And then, of course, you collaborate, because you can do this with different from learners within the same discipline, but it often also good at university level to have students from different disciplines. And of course, in astronomy, that's so easy because often we have students from all around of campus. And then it might or might not involve technology, because as I mentioned, so far at universities, mostly it's been done with engineering faculty universities. So that's why it often involves either prototyping or designing something. It requires flexibility. And this is something that in the past, we might have thought learners don't want things to change. They want something, easy to follow. But it seems like they're really happy with this uncertainty of the project, where they have to constantly think about many facets of that project rather than one. And as I mentioned, multidisciplinarity. So having a view from different disciplines rather than all thinking the same way, having this interdisciplinary view, because engineer would think differently than a lawyer or a designer. So having these fresh eye look on a same topic always helps. And then, of course, involves something innovative and creative, whether it's just the design of a sort of a protocol or even prototyping something. And then obviously you have to define challenge, and that's to the educators, because you can give them something that it's very open-ended or a bit less open-ended. And you as educator would go gauge what for your learners will be the best, because obviously you can't give same level of challenge to primary school or high school. So challenge definition is important. And this is where at TUE, where I'm at the moment, at Eindhoven University, we have basically for the last 3 years, they started a lot of experiments, as they call them. So a lot of courses that are CBL based. And it's really amazing to see a variety of these challenges, because some of them are completely open-ended. So Netherlands Space Office, for example, comes and say to them, we have so much data, do whatever you want, think of something. And one of the first student project that actually got turned into a startup was where students realized that it's really useful to use satellites to observe seaweed farms. So it's more environmentally friendly because the farmers don't have to jump on the boats and ride all the way there. And if they do that once a month, they might miss some issues and the whole crop can get destroyed. Whereas if they check satellite imagery that this student group now provides, they can have kind of a better response if anything needs to be fixed. So that's an example of a very open challenge where what we call a challenge owner doesn't have any preconceived kind of needs. They just have a product, which is data, and they'd like anybody to do anything with that. But on the other hand, we have projects where there's a project owner that creates a certain part of a machine to do with combustion engine, and they just want that to be more sustainable. So the students don't have to redesign the whole engine, but just that part, which is the crucial part with the CO2 issue. And so that, although that's not too open-ended, it's still open-ended enough that students can do whatever they want. And then if there's a need to redesign the engine itself, then they can say, yes, this would require further changes. But this is kind of starting from a little bit more constrained, but still, with the possibility of open challenges. So this is all I have. And what I wanted to do is I've sort of just gave you some examples. And then what I wanted us to do is think about what kind of activities and topics would be more suitable if we are to make astronomy challenge-based class. So I'll stop my sharing. And I've created a Padlet wall, and I'll just share here. And then if you have any questions, I can answer question, and then I can talk a little bit more about what topics in astronomy we could tackle. Can you hear me?
We hear you fine. We don't see anything on the screen right now, so
yeah. Okay.
Haven't seen the Padlet yet.
Yeah.
Oh, it's in the it's in the chat now. We see the link for that.
Yeah. But before I go on, does anybody have any questions right now?
Yasmin, I haven't seen anything in the chat that's come up as yet. I think we've got a shy group today, or
that's okay.
They're on lunch, or but whatever you did with the sound has worked. So whether it was moving room or switching the video off, we've heard you since then perfectly clear.
Okay. Well, I don't expect much. It was a bit dry at the moment, but so I'll share the Padlet. So these are some of the topics that I used to use with my students. So this is astronomy. I mean, in astrobiology, we had different ones, but these are kind of topics in astronomy that I used to give them. So I kind of put them there as a starter point. But the original idea was for us to break into groups, into Zoom groups, where people can just go as a group and work on particular challenge. But the other way we could do it is that everybody just work together, and we just keep adding kind of topics or ideas underneath and discuss them as we go, because we don't have much time left. But I can give you examples if you like for these four, and if that can kind of kickstart the discussion, or we can just discuss them as a group and write them quickly. Does anybody have preference? Sorry, if I share the screen, I can't see the.
Everybody's so quiet. Come on, people, let's participate.
I mean, if people are quiet, I can continue kind of adding things, and then you can just say yes, no.
Yes,
Okay,
Adriana
we're seeing
says
some.
climate change.
Yeah, climate change. So that's good about how observatories are affected. So I tend to use a lot of opportunities when I talk about Mars and Venus, obviously, to explain how climate change works, because you probably know there is so much confusion about the weather, changing weather and changing climate. And people are constantly saying, what kind of global warming is this when it's so cold now and things like that. And so that's the one way whenever it's something to do with Mars and Venus, making people understand climate change better is a very good topic, because you're not confronting learners with Earth. You know that psychology, that that people are resisting climate change because they have to change their behavior, right? But if you say this is how CO2 cycle, this is how CO2 planetary cycle works, and this is why CO2 exists. You show them the planetary evolution. This is why CO2 exists as a primary sort of atmosphere gas. And then this is what happened to Venus, and this is what happened to Mars. This is why it has thin atmosphere. Then learners seem to be much more open to exploring themselves how CO2 cycle works and why adding more CO2 doesn't help. So some of the topics that we had when we given this as a topic for the project, this was brilliant. One of the students called several sea resources, because Australians love to travel and they like to go to tropics a lot, and they like to go to Bali and other places that are nearby as well. And so they asked them, how will you be affected by rising temperature and rising sea levels? And you would not think that that's a topic of astronomy, that's just a social topic. But of course, what students refer to is that these places are often places for astrotourism as well. And so they started to link the fact that if you want to share astronomical knowledge and you bring people to these dark sites, they will have to stay somewhere. And then if these businesses get affected, it might be more expensive because they'll have to redo some parts of their houses or things like that. So that, to me, that really blew my mind, because the students basically started comparing how much stars you can see from Australian desert versus, Bali and stuff like that. Because Bali, although it's, where Australians go, although it's quite developed, is still quite dark. So students managed to weave this in from kind of like a fun touristy point of view, but actually started, tackle something real that affects people. And I think this is the topic that, okay, so I'm just reading that, that you do discuss topics at primary, secondary level. Yes, good. If they can be the part of solution and not the problem. So this is exactly what challenge-based learning bringing to students. So in theory, challenge-based learning has a lot to do with project-based learning, a lot to do with problem-based learning. So it's not completely new, but I guess some of these key characteristics are that you are really get into learners. Exactly what you said, Amit, is that they can be part of the solutions, because sometimes students feel very depressed when you tell them about how things are going bad. And that's not what we want. We don't want them to feel depressed. We want them to feel that they have power to change things, but we have to teach them how to tackle these problems. And sometimes, it's within the courses that we throw at them, either high school or primary or university level, they sometimes get lost in this content and forget about using that content for something. And, you know, my kids used to go to International Baccalaureate School in Australia, and there it's all project-based. And for them, it's so natural to think about solution all the time. You know, there's a project, and first they need to find a solution, so they have to research and find things. So if we install that in, and then my university students come and say, you know, when we have our classes, they say, oh, this is like primary school again. This is fun. So it seems like, you know, sometimes the way we teach maybe kills some of that creativity and agency that we want to build in the students. And I see that people are interested in spin-offs. Yeah, sorry, I had to turn my camera off so that you can hear me well. So spin-off is something that I use a lot whenever I'm asked by public, why invest so much money in telescopes? And then, of course, you know, when there's so much problems to solve on Earth. And of course, then we teach them how much of spin-offs we had from all the various astronomical instrumentation. But also as a PhD student, I used to travel a lot to European Southern Observatory in Chile. And I learned a lot how much that kind of lifted, obviously, the scientific community in Chile, because those astronomers had access to, you know, world-class facilities, but it also lifted the economy because the relationship between Europe and Chile then improved, and there was a lot of economic benefits as well. So people often don't understand that astronomy is done by people, not by telescopes. So that, you know, there's a lot of people we train and employ. And so spin-offs in that respect are very important, but also technological spin-offs that we all know very well. And I like the comment here on the Padlet that it's very good to have students suggest ideas for spin-offs that don't exist yet. So that I think it's also good. And I think NASA has really good activities for that in terms of space technology. But I think astronomy now has become such a tech-based discipline that we have so much to offer in that respect as well. And I noticed we have some comments for equity and diversity. And I agree with Rosa that this is the key. So what we started, for example, in Monash 2 years ago is a science unit about indigenous astronomy. So I'm not sure whether you know, but Aboriginal astronomy nations are one of the, you know, longest continuous among longest continuous nations on Earth. They've been, you know, there for at least 40,000 years. And they have oral traditions, so a lot of their knowledge is transferred orally. And when first colonists came to Australia 200 years ago, they mistaken all that knowledge just for stories, for myths. But of course, modern science recognizes that that knowledge is more than just a myth. It's a way of transferring really complex knowledge. And of course, astronomy, they're very strong in astronomy. They use those observations for figuring out where to hunt, what to hunt, and things like that. Obviously, they've followed the seasons to know where to move. They could predict from, you know, just observing scintillation, which of course we now call scintillation, but just observing stars, next day they will know whether it will rain or not. So there's a lot of these indigenous knowledges, which people kind of used to dismiss because they prefer to treat these indigenous nations as primitive. But of course, now we unpacking and they're sharing with us this amazing knowledge collected over the, you know, many hundreds of years. And of course, because they still persist on such a harsh land like Australia, they have so much knowledge about sustainability and other issues which could help modern societies. So we want to support this equity and diversity, not just in terms of gender and race, but also in terms of these past injustices that have happened, and help acknowledge and you know, raise awareness how much of this knowledge is actually useful for today's living, but also to kind of give it a status of the current, modern science. So this is where I think more across the world, this indigenous or archaeoastronomy is being revived, which is great, because it really brings unique way of observing things. And there is so much to research there because, at the moment, at least in Aboriginal astronomy, we just scratch the surface. And what's beautiful about working on projects like that is that, of course, you have to work with a community member, because you have to have permission of sharing that knowledge. And, if you publish paper, they get to be on a paper with you. So their scientific knowledge is acknowledged as well. So it's one way to tackle societal inequity, for example. And then I see here about sustainability comments, that moving towards sustainable energy technologies, we need public to understand these issues. And then we need all kind of technology to develop renewable energy and green technology. And you probably heard last year, I think it was last year, there was a presentation in one of the conferences where somebody compared, for example, the energy requirement of high-speed computing that astronomers use. We used to focus just on the flying, and we're flying too much with our conferences and stuff, and we producing CO2. And then it turns out that our computers that we need for our, huge amount of data also create almost equivalent amount of CO2 gases. So astronomers tend to be quite, I'm biased, but I think astronomers tend to be quite good at this. We tackle some of these gender and racial issues, started to tackle them before other disciplines, and now with the imprint. So in terms of sustainability, we can give students a lot of that kind of challenges to say, if you are to build, the best telescope in the world with the fastest computer in the world, what are your energy consideration to think of? And, so would you then include in the building of your telescope, would you then include building solar panels and, all of this stuff? And students, in textbooks of sometimes we used to, there used to be a problem. Okay, if you have a, city or this, where would be best to build observatory? And it's mostly just to do with the light pollution and, if you need southern sky or you need northern sky. But now we're actually expanding that and say, well, think of your whole imprint. So not just what you want by building this observatory, but what is then the impact that you leave on the planet, and what kind of full kind of hardware you have to consider and include that in the, planning and pricing. And I want to mention, when we were discussing equity diversity last year, for example, a student brought out the issue with building telescope on Mount Kia, for example. So it seems like they really, once you give them this link between topics, some of them really leap towards it. And what they like, especially in the units, in the courses like astronomy, if they're elective and you have students from many backgrounds, what they liked is those open-ended projects can allow them to express their expertise. Because, if science and engineering students are in a group with some of those students from humanities or other backgrounds, they can dominate the discussion. But if you can bring some of these other aspects, then those students can flourish as well. And they're so happy that they can teach, STEM students some of their knowledge and expertise. So we really find that some of these topics can kind of make appreciation of non-science students to appreciate science and technology more, and then for science and for the science and technology students to appreciate more that science and technology cannot exist without, input from all the other disciplines. So I'm starting to lose my voice. So I might stop here and ask for any questions or comments.
Fraser,
So
you're here?
sorry?
I just wondered if Fraser is here, but maybe he left for a while.
I'm here. I'm here.
Oh, okay.
Yeah, there's nothing coming up in the chat right now. So I suspect people are just listening to everything you have to say. I don't think that, yeah, we need to try and encourage people to speak or to put things in the chat. But right now, there's nothing in there.
That's okay. I think we have some inputs for each of the sort of 4 topics. And what I'm planning to do is kind of start a website or some kind of depository, because I've done a lot of these projects over the years, and I'm kind of slowly sorting them to show an example, because sometimes it can be difficult for educators if they haven't done anything like that. So I'm sort of chasing some of the students to have permission to share some of their work as an example. And so I think it will be easier then, because I think a lot of people probably doing some of this in their courses already here and there, but having a sort of a repository where we can sort of group per topic and have maybe tags so that it's easier to find them. I'll start that slowly, and then we can share through this network or at the next conference, and sort of see with different. For me, the most important thing is at different levels what are more appropriate challenges, because I mostly worked with upper high school and university level, and with primary schools, we mostly work with satellites, which is kind of more space, I guess, space tech rather than astronomy. So I'm really interested, how would this be interested for primary school students, for example? And which topics would be sort of doable for them in that respect. So that's what I promised to create at some point this year and share. And that's the way to kind of start a conversation, to continue conversation further.
We do have a very polite Rosa with her hand up. So I think Rosa wants to come back and ask you some questions or make some comments. Rosa, go ahead.
You know, that is not typical me. Once in a while, I remember to do that.
I was trying not to put any surprise in my voice when I said it.
No, I was just willing to ask precisely that to Jasmina. You know, we have a big network of teachers that are willing to embrace innovative projects as the one that you are sharing with us. I actually never heard about challenge-based learning before. I think it's potentially very interesting. And I would love, you know, in a network like Global Hands-on Universe, where we have people from all over the world, from urban areas, rural areas, from islands, people with very good internet facilities, people with only a smartphone, and people with nothing at a regular basis. I would love to see a global challenge. So I think that Global Hands-on Universe is in a position to support you whenever you have such an idea. We can just, you know, inundate our social media and our newsletters with the invitation for people to participate. Although I do think that for the regular participants that we have in terms of teaching community, it's more likely that teachers from 1st to 9th or 10th grade are the ones that are more likely to participate, because from beyond there, they have exams and life is a little bit harder.
Yes,
so,
and that's the group I think would benefit from this the most, because we know that kids turn off from STEM very early on, especially girls. But these hands-on and you know, girls particularly like to work on something that they see impact, right? So this is where we really like this. And I have a colleague in Monash, for example, at University in Australia, who started this kind of project between Australian university and Japanese university. And you know, it's great for students to have to be confronted with different culture and having to, you know, they worked remotely before COVID, you know, and having to worry about, okay, the time difference is only 2 hours, not too big, but you know, having to take into account all of these things. So I would love to have my, you know, Australian students working with students in Africa, you know, or vice versa. And I think for kids that age now with COVID, they're kind of more used to Zoom and things like that. And having these chats or, learning English through this, maybe through this work as well. I mean, there's so many dimensions that we can add to this. And what I like about this is that you don't really need high tech for this. All you need is a sky and paper or some pipes. And my students made several telescopes for some primary school, just as a fun to see whether you can make telescopes out of pipes and things. And so yes, I think that will be the right age that I would aim for. And this is what I wanted to engage with this community, because as I mentioned, my teaching experience is mostly for the high end. But I think most benefits would be, because at university and high school, you might have a course or two where you might introduce this. It doesn't need to be every course, but I think at a primary school level, you can have this project as a weaving thing through all of the topics you teach students, maths and societal issues and biology and astronomy. You weave everything in this. So thank you. That I'll be in touch with you then.
I'll put my email here actually to anyone who wishes to contact us in the chat.
This may be another one for Yasmina and Rosa to discuss, but Yasmina, I'll throw it to you first. There's something in the chat from Ihsan Ibrahim, and they're asking if you can give an example of diversity and equity project that's possible, and one that can involve students who have very uniform backgrounds and remote locations. And by uniform, they are suggesting social and religious backgrounds. That probably covers quite a few different aspects.
So one example that I used, I think it was a grade 4 and 5 students, and they were from unprivileged school, but very, unprivileged sort of part of the town, but very keen and motivated learners. It was about understanding, for example, issues that we don't all see the sky the same way. So kind of introducing some ideas, we have the Milky Way, which we all talk about. And then you say to them, so why do you think this is Milky Way? Why do you think there's that name? And then, we discuss this Greek or Roman heritage that we have in Western science. And then we say, how do you think people in other countries would see this? And then, because this school did have a little bit of cultural diversity. So then one of the Chinese students remembered that it was called something different in China. And so then we started talking about why did that matter? So there was a lot of discussion around why we name things certain way and what that tells us about the value in our culture, for example. So that's one example. Another one I've done with my student who was visually impaired. And he came to me first as a first-year student with no warning. I mean, they had support from our, we have a student disability service, and they provide some support, but astronomy is different than just needing extra time at the test and stuff like that. And I was quite taken aback because that was the year that I was flipping everything, and 250 students, and I tried to help as much as can, but he was very, very shy and wouldn't ask for anything. And I would throw 3,000 emails at him saying, this is what we're going to be doing. And, do you want me to prepare something beforehand? Can I do something? And I would never hear back. And the student done very well. He had a mathematical mind and he done very well. But then he came back as a third year. And then he was more talkative. And I said, why haven't you answered any of my emails? And he said, I can't read emails. It's just too much. If you want to talk to me, just talk to me. Don't send me emails. And I said, oh, right. And I always mention that as how, the way that I communicate with students, which is mostly emails, right? It did not work with this student. And then I employed him after he finished third year with me with astrobiology. I employed him to come up with resources, for example, that explain things better, not just to visually impaired students, but to regular students as well. And the best example is when we talk about galaxy structures. students had a lot of issues when we say, is this, I gave them Galaxy Zoo and they had to kind of classify them, and they would sometimes struggle to, well, is this, spiral, is this elliptical? And we realized if we print them, if we print some of those galaxies with this bubble paper that they use for visually impaired students, you can actually tell much better, because your touch is more, the grayscale, no matter how much you kind of try to find some kind of scale to print the image, it doesn't convey these subtle changes as much as the touch is. So this is another example where maybe these issues can be shown mostly. I call that, viewing the sky with different eyes. Whether it's to do with cultural naming of object, whether it's to do with how we, represent information by sound. Actually, I'm working with a student, he just finished university, but I'm still working on him on a sonification of some of the things. Because again, people who have diabetes and stuff, for them, tactile is not good enough. And so for them, sound might be better. So these are some of the examples. I'm not sure whether they're good, but this is what I want, diversity works. I want to have input from wider network to see what kind of settings, what kind of topics would be best for what kind of settings.
Thank you for your explanation. Thank you very much.
Thank you both. We're just approaching the hour, so we're almost at the point where we need to call it to a halt, but I'm happy to let it run another 2 or 3 minutes if anyone else has anything to say. Rosa, I know you've worked a lot in Europe with diversity, and we have colleagues that are experts on this. I didn't know if you had any additional thoughts or comments there. I mean, diversity is one of the keys, isn't it?
Yeah, I mean, even in a continent like Europe, where you have so many wealth countries, and where you would imagine that everybody would have similar opportunities, we know that is not reality. And diversity is a very important thing for many things. You can talk about cultural diversity, you can talk about social diversity, you can talk about cognitive diversity. There's so many aspects and layers to that. And I don't know, for those who saw my presentation yesterday, I'm becoming more and more devoted, and maybe Yasmina can adopt this as well, the use of design thinking for education, which is a model where you get to know your audience before you start developing the challenging. So you kind of co-create things with them. So it's the best solution for them. For instance, we have here a very quiet audience. We should include maybe in the future a few design thinking activities to ensure that we know the audience that we have and how they are going to respond to any activity. So we are prepared to help them take the most out of it. These are things that we are working very heavily at the moment, and that maybe you can consider for your challenge-based learning, because this is a big part of the challenge, how to make sure people are included.
Yes, so at university level, they do include the design thinking, because as you mentioned, you have to make sure that the solution, that you understood the problem that the challenge owner gave you. But I really like your idea of doing that for workshops as well. Mm-hmm. Because, I somehow expected that, these are a lot of educators, and I thought, they're just going to jump in. But I guess it's like students, whenever we switch the roles.
Teachers are the worst. Whenever they are in the role of students, it's really complicated.
Yeah, but I also like the fact that you talked about yesterday. Is just that before, it was kind of gender diversity, and then we started to think about, okay, so not just gender, we have all these other things, and so this is where I'm still trying to figure out which of those topics would be more suitable for what kind of level, because as we saw from this example here, I never had such a kind of uniform background. In Australia, I'm so used to really diverse background of students because Australia is a multicultural country. So almost everywhere, even in the kind of rich, posh schools, there will be some cultural diversity. And so people will always be able to chip in view, different view, if you ask them, if it's safe space to ask them, you know, do you remember any stories about sky from, you know, your grandparents and stuff like that? So this is something really important to consider.
We just have one more question. As you probably know, the whole event is being broadcast on Facebook. So we have people who are kind of sitting on the sidelines and watching. And we have a question there. In fact, we have another one come in as well. So we'll keep you another couple of minutes if we may. We have a question from Vindra Kanai on Facebook who says, how well does your CBL approach work with older groups? So have you worked at all with people? And I feel picked on here, but he's chosen 40 and 50 as the age group, as defined as older.
So this is what we had in a MOOC. We had a lot of people who, you know, the kids were younger, but they wanted to see what professions their children will have in space age, and grandparents who wanted to see what will be the profession of, and they loved it. And this is where they said they tried other STEM courses and they found them just too full on, and they're saying, oh, my brain is just too slow now to have to deal with so many facts thrown at you all the time. And what they liked about the CBL is that you're given a structure, you're given this skeleton of information, and you fill it up at your leisure, right? So if you're only interested in following, let's say if you have to find the way to make water, and we say to them, here is the skeleton of 30 ways to make water. You can pursue all 30 if you want, or you can just pursue 2. So what they like that flexibility of CBL, and also they like to be challenged, because again, similar like young children sometimes. My daughter she's 12, and she said to me the other day, oh, I wish teachers are not trying to make things too easy for me, right? So she feels patronized, like she's 12, she's big now, and she feels patronized if it's made too easy. And I think older people as well, I see that by my mother, if I try to help and make things too easier for her, she said, well, I'm not a child, I can do this. And so I think that's where the challenge-based learning power is, that it's flexible enough that the learner themselves, depending, even if you have age diverse group or diverse group in any way, anybody can pick a task or direction in that project that suits their skills and their level of challenge they're prepared to do. So yes, I think it's from 5-year-old to 105-year-old, I think it works.
Sounds like our teachers need to be brave, right? They need to know that they're going to be thrown lots of challenges themselves as in the way of presenting this. One final comment on the chat, which I think is a question, and then we should probably wrap up at that point, is from Amritanshu, and it says, have you got a framework at the moment to ideate, prototype, and test design thinking process for an upcoming workshop?
I'm not sure what does it mean by upcoming. Does it mean is it next one that I want to plan?
I don't know if that's what's being asked or whether it's, yes, that's what's being asked. There you go.
Yeah, so I wanted, with this first one, I wanted to collect some topics that people find interesting, but maybe this was too sudden. So what I might do is maybe through this network, send some more information and maybe a kind of selection of topics that people can kind of rate. And then we can create more concrete workshops of how you would implement this, because I think it's so wide what we could do, but it has to be, there's a limitation within the topic that you can do in that respect. And so if that's something that you would be interested in doing, I'm happy to run some of that. If we kind of zoom in on maybe top 3 topics, or even just these 4 that we run through this process. So yes, I'm up to the challenge.
That's fantastic. Fantastic. Thank you very much for your time today and for seemingly solving the sound issues at your end as well, and a late evening for you as well, by my guess.
Yeah, it's at 3 o'clock here. I'm actually on holiday at Montenegro, so it's it's just 3 o'clock in the afternoon, so it's not too bad.
Fantastic. Okay, great. I'm going to pass back to Gustavo. I think we're done for this session right now. Is that correct?